Okay, this is a racing car from 1906. 1906 is our Naudin. Now, Alan is going to break an unwritten rule. A lot of races have written rules. Alan's going to break an unwritten rule about classic old cars. And stay tuned, we're going to show you the whole thing. Hey, good day to you, Alan. I see that you have parts and pieces under the Sizaire-Naudin again.
Yep.
What's going on? What do you have up to here?
Well, I was done, but the first time it's going to really be publicly shown is a couple months away, and I'm still having trouble starting it. And I just, I can roll down my driveway and I can get it running, but to hand crank it with a twin fire mag is just impossible. You know, it's got high compression. This is a race car. It's much higher compression than another car like it of its time. It's also got a giant, almost 100 cubic inch cylinder, single cylinder. Wow. To make it fire, it's got to fire a mag. And most cars in 1905 or 1906 were make and break ignition, which means as slowly as you could crank the car over, and as super slow as you want, as soon as you break the contact, you have a spark which ignites your fuel. Okay. This is a twin fire. Every revolution of the magneto needs some speed to make it go over. This would be the same thing as if it was 800 cubic inch if it was a V8. You know, you've got a big single cylinder motor. A big single cylinder motor is one of the most difficult cars to start by hand cranking if it's got high compression. Because when you have to go around twice before it's going to fire, and if you can't keep it going and make the mag at speed, I can't.
Okay.
And that's what I think sometimes in our hobby, once people get to be in their 90s, they start slowing down and driving their old cars. And I think if they had a mag on there, I'm doing this for 20 years from now to make it better for my wife and I 20 years from now. Instead of my wife always getting out and push starting us, we're going to be able to push a button.
She must be thankful that you're doing
I think she's going to like this one.
Okay, so what are some of the considerations when you've got an old car like this and you decide, I need to figure out a way to put a starter, and obviously you show this at car shows and things. You want to not be very obvious that it's modified.
Yeah, I want nobody to watch this video. Okay. I want nobody to know that I have a starter on here. Because this car doesn't even have a battery. This is completely original.
Right.
Yet I can't start the dumb thing.
So you're going to do something.
Yeah. So you're going to hide it. Right. And then also on antique cars, you have a flywheel that was never designed to carry any teeth or a ring gear, and it's in free floating in the air. There's no frame members close to it. And this is a wooden car.
So what was the purpose of a flywheel? Because a lot of times we think of a flywheel as with starters. So
a flywheel is a flyweight by keeping a lot of weight. This has got 3 flywheels. It's got 2 inside the cylinder itself and 1 on the outside. Okay. And all totally into about 200 pounds of rotating mass. Wow. And if you're going to smooth out a single cylinder that goes 60 or 70 mile an hour at full tilt, you need it to be balanced some way or another.
Yeah, that's a lot to overcome, right?
So
you have just 1 piston.
Right,
moving.
1. So it's a lot, and that's what this formula was for this racing series. Okay. So it's a difficult car. The good thing is about the flywheel, and I'll show you about that in a couple minutes, the flywheel on the outside of my 3 flywheels is symmetrical all the way around. Okay. So they never took weight out of the outside flywheel. It's simply a smooth flywheel that spins, and it contains the clutch. And it contains the bath for the clutch. In fact, the clutch, I'll show you in a couple of minutes also, is the original clutch from 120 years ago. It's steel to steel. And the bath of the clutch is this is a total loss motor. So through the crankshaft bearings, it drops a drop or 2 or 3 per minute in that housing that contains oil and lubricates the clutch. And the clutch surface and the flywheel surface are still perfect after 119 years.
So did the balancing happen on the internal pieces you were talking about?
Okay. Yes. So that's something to keep in mind. And also, when you do your ordering of your ring gear, if that's the way you're going to go, if you're not going to cut the teeth in there, you make sure what else that flywheel is being used for. In my case, it's a reservoir for the clutch. So you can't cut into it very deeply. You don't want to mess up what its real purpose is.
Right, right. Okay. Very good. So you've got the clutch. I mean, yeah, you got the flywheel. And so how do you go about getting teeth attached to a flywheel? Can you tell me how?
There's two easy ways.
Okay.
One way is you put it on your indexer on your mill, and then cut each tooth into the flywheel itself.
Okay.
You can do that.
Okay.
The bad thing is if you want it to last another 200 or 300 years, you might wear those teeth out, especially if you have a mistake or you have a snap ring snap on your starter. You could mess up those teeth, and then what do you do then?
Right.
So the other way is order a ring gear and interference fit a ring gear.
Okay.
So you want to find a ring gear that's right between the OD and the ID of your flywheel.
Okay.
And then you want to do an interference fit. So you're actually going to make the flywheel, you're going to cut it less than you need it. This one is about 14 inches in diameter. So it's about 2/1000ths of an inch per diameter of the flywheel.
Okay.
So I'm going to make the ID of the cut in the flywheel about 30/1000ths greater than the ID of the ring gear. Okay. So it won't fit.
Right.
But if I put that in the oven at 500 degrees for half an hour, or use a nice torch, you want to do it uniformly, though. You don't want to do anything to bend it.
Right.
You want to heat it up, and you want to just set it on your groove that you made, move it back and forth a little bit until it seats, then tap it around, and then that's an interference fit. And that's going to be on there forever until that wears out 150 years from now or something.
Yep.
And then you can cut it with the new Dremel tools at that time, or use your punch and drive it off there.
Excellent. All right. Well, we will follow your progress as we do this then.
Okay.
Let's do it. Okay, looks like you've got some progress made. You've got something taken out of the car.
Yeah, this is the transfer shaft that the pedals move on. So this transfer shaft bolts between the two frame members.
Okay.
And in this case, the frame members are wood because it's a wooden car. There's steel, there's the 1/8 inch steel on both sides, a cladding, but it's basically completely a wooden car. So as it turns out, this bar sits about 1/2 inch in front of the flywheel.
Oh, really? Okay.
Yep. So to make a sample of what I need to do, if I basically cut this out of this plywood, if I put this on this bar, the starter, whatever shape it is, the center of the gear needs to protrude from this and go 3/4 of an inch to hit the flywheel.
Okay, you measured that out. Okay.
Yep. Okay.
Excellent.
So the next step you do, you create your mount. Well, I guess before you do that, you find out what ring gear you can get for your flywheel. In this case, a 1955 Chrysler Hemi ring gear fits my flywheel.
Is that right?
And that's a 146 tooth ring gear. There's companies that make starters for that, but you don't want to use an old starter for that. You want to use a very modern starter. A modern starter is round where the head goes, and it's indexable.
Right.
So you're not going to use this plate that comes on that starter that you're going to buy from Speedway Motors or whatever company you want. But the mere fact that it's round, you can place it inside of something like this,
right,
and move that starter to make sure that you don't have any fit problems with your running gear, your exhaust system, your boards, your footboards, your sides.
Yeah, because you want it to fit just exactly in a certain way.
You want to do a really professional job of it.
Right.
So the next thing you do is you figure out what side of the flywheel it goes on. The engine in this race car, the Sizaire-Naudin, spins counterclockwise.
All right.
They did that for the racers in 1906 so they could put the rear end also upside down and give them more clearance.
Okay, right.
But you don't have to worry about that when you order the starter and the ring gear, because that just means you either put the starter on this side of the flywheel or that side, just to make sure the rotation of the starter that you're using is a way that it's going to spin it the direction you want it to spin. In this case, I want it to go this way.
Perfect.
Okay. So as long as you have clearance there, and if you're using a transverse bar or a crossbar, then you can make it work. So the next thing you do is, this is my starter mount.
Doesn't look like much of anything.
Well, it's going to be. So these are going to be sandwiched together.
Okay.
Okay? And I'm going to put 4 bolts through here, drilled on the mill. Okay. And then before I tighten up the bolts, I'm going to put some 50 thousandths washers. One there, and there.
Okay.
So when I put this on my mill and bore it with a boring bar, I'll bore it exactly the ID of this bar, the exact size of it. And then I'll get it within 1/1000th of an inch or so. And then when I go to put it on the bar, I'll simply take the 4 bolts out, let the 4 washers drop away, and it'll tighten up and sandwich that bar super tightly.
Right. Okay. So
and then what I have left, I have 30 or 40 thousandths of an inch gap.
Yep.
And if I tighten them all the way, I can even flex these pieces of aluminum to make it super tight. I don't need to, but it's going to be perfectly
so those washers just create that extra space to pinch it.
And the neat thing about building a mount like this on a transverse bar is, this is my approximation of where the center of the starter needs to be, where it hits the flywheel.
Right.
But this is just out of a piece of plywood. I can make this with my piece of plywood form because when I get all done, I can move this way, which is closer to the flywheel, or that way, which is further away, to get my clearance correct.
Right. Okay. So you've created a movable mounting spot there to match everything up.
And the same system that I'm describing works perfectly if the pedal bar isn't anywhere near your flywheel.
Okay.
It'll work fine. You just mount a bar between your 2 frame members that you can make a mount like this.
Okay, Alan, catch us up on where you are with this.
Okay. Well, it's been a few days now. We got our ring gear, and we cut the flywheel down. So it's now the same ID as the ID. The OD of the flywheel where the cut is the same as the ID of the ring gear plus about 30 thousandths of an inch.
Okay.
So then I put this in the oven, turned the oven to 500 degrees, got my welding gloves, placed it on here, wiggled it back and forth, tapped it in place. Now it's interference fit, not glued, not screwed, nothing. It's on there forever. While we're talking about this, this is the original flywheel. All the parts are original. This is the clutch disc.
That's massive.
15-pound clutch disc. That's why it's not worn out after 119 years.
Right.
This disc sits on this.
That is wild.
And then that's your clutch.
Wow.
And it's got springs here that push it down, and these springs are adjustable. Okay. So a clutch in an old car can last hundreds of years.
Wow.
I'll show you a problem we had, though.
Okay.
I had this nut is inside of this, and this tightens up against the flywheel cone. This is a 50 millimeter, which is 2 inches in diameter, and I needed a socket that went down 6 inches. Nowhere.
Just get that from the hardware store.
Well, it's Thanksgiving. So it's Thanksgiving. They're just not open today.
Right.
Plus, their biggest socket is 1.25 inches.
Yeah, right.
So there's places, and then I had a couple sockets around that make sockets that are soft. It's a freight company that sells tools, and you can tell if the socket is soft enough for you to machine it, because if you can make marks in the socket with your fingernail, that's a good candidate. Yeah. So I used one of those, and I simply bored it out.
Oh, wow.
And since the metal was very soft, it was easy to bore it out.
Okay.
And then I made my own deep socket, 2-inch diameter or 50 millimeter socket to take this off with, and now I can take this off.
Awesome.
So that's my Thanksgiving Day wrench made with that freight company's Chinese sockets. And machined this off nicely and press it in there.
Yep. Very nicely done. And it works.
And then bore it out so it fits over the cone on the inside.
Yep.
So you can, those nice soft sockets, you can make things out of.
There you go. Just don't leave your fingerprints in them.
Yeah.
All right, I got to see how this looks down in there. See? Okay, Alan, here we go. How's progress on this?
Good. I turned those 2 pieces of aluminum into a bracket. This is my bracket, all milled out and finished.
Yeah.
Okay.
Right.
And then so what we're doing is we're replacing this with these 2 pieces of aluminum. Because for our application, this won't connect to this.
No, right. It sure won't.
So then this simply bolts to here and to here, and you can move it back and forth to engage your flywheel.
Right.
We test the starter. Also going to show what the solenoid, or maybe you call it Bendix, what it does. This gear, when you energize it, moves out about 1/2 inch to your flywheel and engages, and then runs back inside again. You can also mark on your starter which way it's spinning also. So now just simply touch this to ground.
Wow, it comes out a good ways. What do you use to energize this? Because normally I don't think there's a battery and an alternator and all that on your car.
No, there's no battery. So, and you don't want a heavy battery. When you start the whole process, you think, well, starter weighs 30 pounds and a battery weighs 40 pounds. And all your hardware, if your brackets, you're going to add 80 or 90 pounds to the car, and the car only weighs 1,000 pounds. So that's why sometimes you shy against doing this. But the only weight I'm adding to the actual starter, and this is all aluminum, is this piece here. And with me whittling it down so much, it doesn't weigh a lot more than this, which is almost nothing.
Yeah, right.
So this weighs less than 1 pound. And then so you want to keep that same strategy. You have no generator.
Right.
So you get a battery. And you find out what the specs are of the starter. This one with full draw on it can draw as much as 60 amps. So you get a lithium battery like this, which is about $250 to $300, weighs 2 or 3 or 4 pounds. This is a really big one of these. So this will be able to start this car for 6 times a day to 12 times a day. Which would be more than enough to get me anywhere I want to go to.
Right.
Because still, with you driving a car this old, if you can park on a hill that you can just release your brakes and your clutch and coast down, not even use your starter.
Right.
So the total amount of weight I added to the entire car was the 2 or 3 pounds here, and the pound there, and then it's 2 or 3 pounds the starter adds.
Yeah. So where are you at? Maybe 10 pounds.
Maybe 10 pounds.
Yeah. Interesting. And all of that, I guess all that's left to do for that, beyond that, is just hide a button somewhere where you can reach it.
That's right.
And then you'll be on your way.
And then you can move this bracket back and forth to get it exactly lined up parallel to the teeth. And you move it in and out on the bar to make sure your teeth clearance is correct.
That is really ideal. Yeah, the flexibility you have to modify or to adjust it is perfect. Well, Ellen, it's obvious you've done this before. You've thought about this. And so you're encouraging people with 90-year-old or older pre-starter cars. Oh, one thing I wanted to ask you before we wrap this up. Can you explain why a 1-cylinder, because it sounds diminutive, is harder to start than maybe a V8? Like, let's go the extremes. Why would that be true?
Well, this is, since this is 100 cubic inches for a single cylinder, most V8s, like a 289 Ford or something, you know, with 8 cylinders, it doesn't even get to 300 cubic inches.
All right.
So this is equal to 2 or 3 pistons on that V8. And that 2 or 3 pistons, as you crank through that, if you're cranking that V8, those are small impulses.
Right.
This is one really big impulse.
Yeah.
And it's not a hit and miss motor that's got really no compression at all. This has got lots of compression.
Right.
You know, it's 6-to-1 compression. And that's if you don't advance the camshaft lobes. Then it's way more than that.
Right.
So it's a big deal to start a big single cylinder performance motor.
Can't imagine experiencing hand cranking a 289, but you have a V8 that you can hand crank, don't you?
The script's in the other room, the Faro racing engine. That one I can hand crank pretty well. But also that one is easier to start because it's got a make and break ignition. It's called the distributor in that case, because it's a fairly new car. It's 1915. It has a Delco Remy distributor. But even if I was hand cranking it very, very, very slowly, as soon as I get to the point where the point's open, it fires a spark and sets the motor into motion.
Okay.
This is a magneto.
Right.
You've got to be going faster than that.
Okay.
Much faster than that. And you can't just pull it a little bit. You've got to pull it through 2 strokes of compression.
Okay.
You know, it's got to be that hard spot twice before it's going to fire.
You're right.
Well, it's going to fire at the top of the second stroke of that, but it's firing a little bit before that, but not much.
Excellent.
You know, 5 degrees or so.
Yeah.
Well, we're in day 2 of the starter engineering and installation. So this is a 1906 Sizaire-Naudin race car, single cylinder, very high speed, very competitive car. Anyway, the starter system is finished now.
Yeah, let's have a look. Where we left off, you had shown us how you'd made these mounting brackets.
Said before, 2 1-inch thick billet pieces of aluminum. The bracket can move across the car laterally to take up the wear to the ring. So when you engage the solenoid, it engages perfectly. And because of the design that I adhered to for the starter, the closer to the drive shaft you move the starter, the less clearance you have on the teeth.
Okay.
So I had said earlier yesterday that I'm looking for 1/8 of an inch. If I can be within 1/8 of an inch of the gear face to this ring gear face, that's the starting point. I know there's people that are going to say, well, the specs for a starter are 30 thousandths, 20 thousandths something. Okay, but this is not a flywheel and a crankshaft designed for a starter. So in fact, it doesn't even have any bolts connecting the flywheel to the crankshaft. It's a taper, you know, it's an 1.5 inch taper on the crankshaft. Then that taper didn't have to be perfect. But as it turns out, they did a perfect job with their water wheel 119 years ago. And they did that taper perfectly on both pieces, the flywheel and the crank. So when I got it together, when I did my setups for the amount of spacing between the starter gear face and the ring gear face, I was able to get it right at 30 thousandths of an inch.
Wow.
Which is within spec of cars.
Yeah.
You know, in a car, you mount it inside of the bell housing, which is a machined thick piece of housing. This is a wooden frame race car that not a single piece of it is connected together. There is no frame. You've got sandwich pieces. So to be able to do that and be within 30 thousandths of an inch gives me 100% of the starting engagement.
That's pretty wild. So I wonder, are you able to show us without starting the car? Can you show us how this engages?
Yep,
to the
I can.
flywheel?
So I'll keep the ignition off and I'll hit the starter button now.
Okay. Wow, it just comes right on. Yeah. Excellent.
So now it will crank it over. I have the petcock open right now to show you, but I could close the petcock and it's pretty much the same thing.
So how did your calculations go as far as the draw of the starter on that battery?
Okay, we can show that now.
Yeah, let's figure that out.
So the battery I got was the biggest of this series of batteries. This has got 600 cold cranking amps. I knew I wanted a bigger battery than not. It's still a small battery. It still weighs less than 5 pounds. It's a lithium battery. But now I'm going to make sure how much it's drawing. Again, it can do as much as 600. You certainly don't want to do that. If you're at 200 or 300, you're probably within spec of it. So this is a fluke meter, and it measures current by what's going through the wire. If you're not disconnecting anything. So I can lay this here, and now I can hit the starter button.
Okay. Right on.
So we're at 135 to 140 amps. I could have gone to a smaller battery and done the same process. But since I have no generator whatsoever, and because a tour or a race or a whole day might be starting the car 10 times, it's nice to have a reserve. So since the battery only weighs 5 pounds, I'm going to keep this battery in here.
In the previous segment, we saw that giant clutch disc, and now we see it all put back in. Can you show us how that works?
Yep. Well, here's the brake that's inside of the rear pumpkin.
Okay.
So that brake is using the inside of the pumpkin and expanding a shoe, but it's inside of the grease of the rear end.
Oh, really?
So it's got a coefficient of friction of 0.1, my manual says,
okay,
because it's got grease in there and oil in there. But then the clutch is here.
Okay.
And you can see that the clutch disc move back and forth.
Oh, yeah.
But that's also a misnomer. It has no clutch disc. It simply has two pieces of steel. You have the flywheel, and you have a giant other steel disc.
Right.
And then you oil it. There's a reservoir that you oil. So, and then the extra motor oil from the total loss engine feeds in there a drop every minute or 2 drops every minute. So lubricates that. But that's what we showed earlier yesterday, that those two discs been running together and been mated together for 119 years. There's no machining necessary. They're still perfect.
Wow. Yeah.
And then you adjust the spring tension there's a collar here on the.
Oh, yeah.
And then if you want more tension because it's slipping, you just loosen this nut and then wind this that way. If you just can't, if you really get sore on your clutch pedal and it's engaging well, you can back it off and make it looser if you want.
Okay, so the adjustment's right there. And obviously there's a brake pedal adjustment also on that. That is fantastic. And then the starter, the clearance looks so good. So let's be able to see how that works. Man, this looks really great. Well, let's put some of this back together, I guess.
Yep.
And show how clean the final install looks. Okay, Alan, looks like a pretty good setup here. These clearances are tight.
So you want to, in an NT car, you don't want to make anything obvious. If you're doing something that's wrong, i.e. you're changing it, you're modifying it somewhat, even though we made virtually not even a hole anywhere in the car, you still want to hide what you did. Right. You can be honest about what you did, but for the 99 percentile people, it's still a crank start car, and it is.
Yes.
So this is the clearance of the footboards.
Yeah.
So I clearanced it so it completely misses it. There's with a second floorboard in place. Mm-hmm. Virtually no modifications to it. Right. In fact, what this is the could be considered the original tow board that you push on when you're in the car. It also gives the riding mechanician the instructions what to do before each race. Lubricate the clutch, lubricate the fiber discs, do your rear end, all that kind of stuff. So this piece goes exactly
right there. Nice. Boy, that looks really great. Yeah, it'd be so hard to tell that anything was ever changed. Oh, wow. It's alive! So let's just remind people, what are you playing with on that wheel over there?
It's a camshaft. We're just in a camshaft from 100,000ths of an inch to almost half an inch of lift. It has no throttle. It's full throttle all the time.
What are the pros and cons? Let's just talk about pros versus cons of adding a starter to a car that couldn't have had an electric starter in the day.
Well, this one is kind of a sacrilegious job to do because for 119 years it never had a starter. Never had. But it's so difficult to start because it has a twin fire mag, and the mag has to have some pretty good spinning done to it before it'll engage. Instead of a make and break, you can have it literally no RPM. So it's just really, really difficult. And being almost 100 cubic inches of single cylinder, you have to go through 2 compression strokes to get it to start. And that's just a lot. I mean, that's really, really a difficult thing to do.
Okay, now how did they do it 100 and some years ago?
The riding mechanician always pushed it.
Okay.
And all of the races that we see in the videos, and I read everything about it, the riding mechanician's job was to start the car. So virtually always, and then when you watch some of the videos, there was usually 4 or 5 people available, and they were all pushing it, and it would get going.
Right.
Because since it has no real carburetor, it has no idle circuit, you have no accelerator, so what do you adjust to get it to run?
Right.
You know, you just don't have any control of any of that. By having a switch, and you're going to drive it in modern traffic, and might stall the engine on going up a hill, you might be super excited when you start the day, but you might get so frustrated by getting in certain situations that you can't restart it again. It takes all the fun out of it.
I would even pose the possibility that it could be dangerous even in our modern traffic to get stuck, you know. So yeah, it totally makes sense to me. Plus, when people look at the video we just showed on how you put it together, you could reverse it out again if you wanted to go 100% authentic. You haven't destroyed anything.
I didn't make actually a hole anywhere. Yes, we did take off 43 thousandths of an inch on the flywheel for half an inch. I think it's going to be enjoyed for the next 119 years also by having the starter available for it. Right. Yeah. And since we're 1/4 of the capacity of the battery, and the battery only weighs 5 pounds, so we could use a 2 or 3 pound battery. We've got the ability to start it 20 times in a day. You know, we've got the ability, if we're going with a group of cars somewhere, and now they say, we're all going to go to lunch now. And then they hit the starter and they're off and they're running. Right. You're cranking, and they tell you, you know, you have a fast car, you can catch us. You can't catch somebody that's 3 minutes ahead of you, no matter what speed you go. Right. If the lunch is only 5 minutes ahead.
Yeah, and then they're eating dessert by the time you get there.
Right, and you have no seating. You know, the roast is already gone.
Very good. Well, plus cars, you know, I know part of your philosophy is cars should be enjoyed and used and on the road. That's part of the deal. So very good, Alan. I think you did an excellent job. So good job.
Thank you.
Okay.